Hello everyone, today we're going to be finding Flag2, which is the third flag for the Hacker101 Micro-CMS v1. If you're just landing here, go watch the Flag 1 and Flag 2 videos first. I'll link those down in the description. This video is going to build on what we've already done. Flag 3 is about insecure direct object reference. The app has a page that's hidden from the home screen, and when you try to view it directly, you get a 403 forbidden error. But the thing is, the view endpoint blocks you, and the endpoint for editing doesn't. So that's the bug we got to find. Let's go find it. Quick background for anyone who's new here. Every page in this CMS has a numeric ID in the URL. So if we check one of these out, page ID of 2. So you've seen 1 and 2 probably already if you watched the other videos, both of these. And we're also going to create a new page and see what ID it gets assigned. Now here's the interesting thing. When you create a new page, the app doesn't give an ID of 3. It jumps to a much higher number. So let's make a new page. And if we check it out, this has a page ID of 12. Now this gap isn't random. There's actually pages in the range that this one doesn't advertise. Some of these return 403 forbidden when you try to access them, and some of them return 404. 403 forbidden means that the resource exists, and the server knows about it, but it's telling you that you're not authorized to see it. So if we get a 403 error on any of these, it's a pretty good sign that there's something hidden there, and we need to figure out how to access it. So what we need to do next is enumerate the page IDs, and we can do this manually or with a tool. I'm too lazy to write a script, so let's do this manually. We're going to just go to page 3, not found. We can try page 4, not found. Page 5, not found. Page 6, not found. Page 7, okay. We're getting the forbidden error on page 7, so this would be a 403 error. Page 8, not found. Page 9, not found. Page 10, not found. Page 11, not found. And of course, page 12 is the test page that we just created. Now, when we go to page 7, which returned the forbidden error, you'll notice the flag doesn't just show up. So somehow it is checking permissions, and the route doesn't exist. So we can't view the page, obviously, when we go to the ID directly like this, because it's blocked. But the app doesn't apply the same access control to the edit endpoint. So instead, what we're going to do is we're going to just add edit in here. And there we go. We are given the flag right here. So we can copy this out and we can go back to the CTF. I've found this one already, but I'll just show you where to go. You go over here, submit a flag, and paste it in there and check it. Now let's talk a little bit about how this specific vulnerability works. The app is using a direct object reference, or the page ID that you see here, to pull data from the database. And there's no session check on the edit endpoint to verify whether the current user is allowed to edit the specific page. The dev secured the view route but forgot about the edit route. And this type of vulnerability is called an insecure direct object reference, or it's sometimes shortened to IDOR. And it's one of the most common and highest paid vulnerability classes in real bug bounty programs. And this shows up all the time in production apps, like order IDs, user profile IDs, document IDs, and the pattern is usually pretty similar across different websites. The app just trusts that a user will only try IDs they're supposed to have access to, and it doesn't enforce authorization at the code level. So attackers can just increment the number and access data that isn't theirs. Be sure to stay tuned for a video on the 4th flag in this competition. And if this helped, a like would go a long way. So be sure to subscribe if you're working through the full series, and I'll see you in the next one.